Alright, here's example 4 with implicit differentiation. So see this function here is the fourth one from our first video, but we're going to do something a little bit different. Find the slope of the curve x squared y to the fifth minus 6x equals 4y minus 13 at the point where y equals 1. So this still involves derivatives, right, because it's slope of the curve. And remember, slope of the curve is the same thing as the derivative. So even though we're doing implicit differentiation and y is implicitly a function of x, all the same stuff with derivative still applies. Okay, derivative, slope of the curve, slope of the tangent line, instantaneous rate of change, it's all the same. It's all still the same. Okay, so let's go ahead and jump right in then. So we want to find the slope of the curve at the point where y equals 1. So there's actually a few different things we have to do. First, let's just find the derivative, okay, because slope of the curve is derivative. So the first step is just find dy dx here, pretty much. So we're going to start by saying x squared y to the fifth minus 6x equals, and then leave ourselves some room here, 4y minus 13. Okay? So now we're finding dy dx, so we have to say d dx of the left equals d dx of the right. Okay? Now what happens on the left? So on the left, we're going to do term-by-term differentiation as always, but here we're going to have the product rule. Okay, product rule is going on over here. So d dx of x squared y to the fifth, remember product rule just says if you want to take a derivative of a product, it's going to be derivative of the first, which in this case is just 2x, and then times the second. Okay, so derivative of the first times the second thing, and then plus the first factor, first thing here, times the derivative of the second thing. So y to the fifth, the derivative of y to the fifth is just 5y to the fourth times dy dx. Okay, because remember we're doing implicit differentiation, and implicit differentiation is just the chain rule, right? So y to the fifth, the derivative is 5y to the fourth times dy dx. Okay? And then the second term, minus 6x, the derivative of that with respect to x is just minus 6. So that's good. Now what happens on the right side? d dx of 4y minus 13. Well, 4y, the derivative of that is going to be 4 dy dx. Okay, so it might be pretty easy to forget the dy dx because it's just 4y, but watch out for that. Make sure to have that there. And then minus 13 is just a constant, so its derivative is 0. So let's not even bother with that. Okay, so here's what we have here. Now we've taken the derivative. Now we need to collect all the dy dx terms on one side and put everything else on the other side. So let's go ahead and, just to keep it simple, 2xy to the fifth, that has no dy dx. X squared times 5y to the fourth dy dx, we'll put that on the other side, and then minus 6 can stay over here, and then this 4 dy dx can stay over here. So instead of moving three things around, let's just move this one. So on the left side, we're still going to have 2xy to the fifth, and then this whole thing is going over to the right, and then minus 6 is still over here. Okay? Now on the right, we have 4 dy dx. And then on the left, we had plus x squared 5y to the fourth dy dx, so we're going to subtract this whole thing from both sides. So on the right side, we now have minus, and let's also rewrite it. Let's write it as 5x squared y to the fourth dy dx. Minus 5x squared y to the fourth dy dx. Okay, so just remember that this is x squared times 5 times y to the fourth times dy dx, and it doesn't really matter which order you multiply things in, but of course it's customary to put the constants first. Okay, the coefficients out here come first, and then x's and y's and dy dx. Alright, anyway, now we have all of our dy dx's on one side, and everything else on the other side, so let's go ahead and factor dy dx. So the left side is still the same, 2x y to the fifth minus 6 equals, now on the right we have dy dx times the quantity 4 minus 5x squared y to the fourth. Didn't really need square brackets, but I put them for some reason. So anyway, dy dx times all this stuff equals that stuff. So now just divide both sides of the equation by this, and then that'll be our answer for dy dx. So let's go ahead and do that. So we divide both sides of the equation by 4 minus 5x squared y to the fourth, and we're going to have, let's section this off just to make it easier to read. So we're going to have dy dx equals, what was over here? Over here we had 2x y to the fifth minus 6. 2x y to the fifth minus 6, all divided by 4 minus 5x squared y to the fourth. Okay. So if you're thinking, hey, wasn't dy dx on the right side of the equation, it doesn't actually matter, because we could just say, this instead. And it's still the same thing, cover that up. It's the same exact thing. The point is that dy dx equals this expression now. So don't worry about what side of the equal sign dy dx is on. Anyway, this is what we have now. So the original instructions were to find the slope of the curve, this curve, at the point where y equals 1. Okay, so we found dy dx. Now we have to find the numerical value of dy dx when y is 1. So we can just plug in y equals 1. We can plug that into here, right? Well, yeah, but then we're still left with some x's here. So what do we do about that? We're going to be stuck with all these x's here. So if we want to get rid of the x's, we have to go back to our original curve. Okay, x squared y to the fifth minus 6x equals 4y minus 13. And we have to figure out, okay, we're looking at the point where y is 1. So if y is 1, we have to also figure out what is x. Okay, and we could have done that first, but I just wanted to do the derivative first just to show you that we actually, at some point we are going to have to find out what x is at this point. Okay, so we know that y is 1. Now we just have to figure out what's x. How do we find x? We'll go back to our original curve here and plug in y equals 1. And that's going to give us the corresponding x coordinate. Okay, because what are we doing? We're finding the slope of the curve, this curve, at some point on the curve. And all we know is that y equals 1 at that point. So now let's find out what the corresponding x coordinate is. So when y equals 1, what's going on when y equals 1? What do we have? We have x squared times 1 to the fifth minus 6x equals 4 times 1 minus 13. Okay, so now what we're going to do is just simplify this and solve for x. So 1 to the fifth is just 1. 1 times x squared is just x squared minus 6x. And then equals 4 times 1 is 4. 4 minus 13 is minus 9. Okay, so now this is just a quadratic equation in x, right? So we have to add 9 to both sides. X squared minus 6x plus 9 equals 0. And then when we factor that, we get x minus 3 quantity squared equals 0. Alright, that's good. So there's actually only one value of x that satisfies that equation, and that's good because now there's just, we know that there's only one point we're looking at. So that's good. Alright, so x minus 3 squared equals 0, that just means x equals 3. Okay, so what does that tell us then? That tells us that when y is 1, x equals 3. Okay, so we're finding the slope of this curve at the point where y is 1, and we just found out that when y equals 1, x equals 3. Okay, so now we go back to our derivative here, and now we can plug in y equals 1 and x equals 3. Alright, so let's go ahead and do that. Let's just erase some of this stuff down here. And we're going to plug in x equals 3 and y equals 1. Okay, so and the way we can denote that is like this, dy dx evaluated at the points x comma y equals 3 comma 1. Okay, so some people like to use this notation, some people don't, but it's valid. People know what you mean if you use it, and it makes sense. So anyway, this just means plug in 3 for x and 1 for y. So we go back to our expression up here, and let's go ahead and do that. when we do that, 2xy to the fifth minus 6, that's going to be 2 times 3 times 1 to the fifth minus 6 on the top. So on the top we have 2 times 3 times 1 to the fifth, and then minus 6. Okay, we'll zoom in a little bit. That's on the top, and then on the bottom, what do we have? 4 minus 5x squared y to the fourth. Okay, so it's going to be 4 minus 5 times 3 squared times 1 to the fourth. So it's 4 minus 5 times 3 squared times 1 to the fourth. All right, now let's just simplify this and see what it equals. So 2 times 3 is 6, 1 to the fifth is 1, so 6 times 1 is 6. So on the top we have 6 minus 6, which is actually 0, and you might be inclined to just say right away, oh, that's 0. And in this case, yes, it is, but we have to be careful. We have to make sure that the bottom is also not, we have to make sure that the bottom isn't 0. Because if the bottom is 0, then, well, then maybe the answer is just infinity, or we messed up somewhere. Most likely we messed up somewhere if that's the case. But anyway, just always double check the bottom. So 3 squared is 9, 1 to the fourth is 1, so 4 minus 5 times 9, okay, and 5 times 9 is 45. Alright, so this is actually 0 over negative 41. Alright, so this is just 0. And that's the answer here. So the original instructions were find the slope of the curve x squared y to the fifth minus 6x equals 4y minus 13 at the point where y equals 1. So just to recap real quick, we had slope of the curve means the derivative. So we found the derivative, it's this guy up here, and we're being told to find the value of the derivative at a specific point, and it's where y equals 1. So we go, okay, we can plug in y equals 1, but what's x? So to find x, we go back to our original curve here, and we say, okay, when y equals 1, we have all this stuff here, therefore x equals 3. So we know we're finding the slope of the curve when x is 3 and y is 1, and then we plug those values into the derivative here, and we simplified and we got 0. So slope of the curve, remember that's the slope of the tangent line. So if you were to actually graph this curve, and if you were to graph the tangent line at the point 3, 1, it would have slope 0, which means it would be a horizontal flat line. So that's kind of what that means there. And that's example 4.